Welcome in. Yeah, we've got some not new equipment. It's been in my garage for about 4 years because I never use it, but I figured I'd show you how to use it, and we'll try a different way of soldering today. You can see I've brought a load more Game Gears off eBay. We're going to try and get a VDP that actually works, and I figured we'd try this other way first, basically. Let's see how it goes. I'm just trying to find that video. I think it was the video from yesterday where we looked inside the back of the Game Gears to see which version they were. I want to see if I can find that image, and then I can just look in the back of all these instead of trying to actually. Why am I trying to look at a video when I can actually just get it? Oh, that's the point. I've got no 2A6, have I? I don't know what a 2A6 looks like. I've got none in stock. The one over here. Yeah, there's actually. We've got one with the CPU still on. So when we look in the back cover, we're after C38, I think is what you see in the back. Yeah, we definitely need a VDP emoji. That is 100% a thing we need. So one of the things we've had, obviously quite a few people must watch these streams. No, this isn't laser soldering. Maybe we'll do that in future. This is just infrared. But quite a few people, rightly so, when we're doing like so many Game Gears, we've had a lot of VDP failures, as everybody knows. But one thing we have to bear in mind is that all of these Game Gears I've been working on up until now, this is the new batch since then, I brought like 100 off a guy in the US. That were ones he couldn't get working, and he knew his stuff because he'd worked on a lot of Game Gears, and these were all ones that he couldn't get to work no matter what he tried. So that's probably why we saw so many bad VDPs in the last batch. Of course, every single one of these has got a cover over so we can't see inside, so we're gonna have to open them all up. So people were basically wondering why were we getting so many bad VDPs on Game Gears. Is it the soldering? Is it the temperature? Is it the voltage going in the re-PCB? Lots of questions. This one looks like it's knackered, it's rusted and rotting. So I figured, even though I'm pretty confident it's not the soldering or the USB or any other issues, it doesn't harm to try new techniques anyway. But this is now a fresh batch of Game Gears off eBay, which is the first time we've used a new batch that isn't a purposefully set of broke Game Gears. So what we'll do is try this new technique, and we can continue to use it and see if we get a good streak of VDPs. And then if we do, I'm purposely going to show you and try and prove that I can completely overheat the chip by a huge amount and it's not going to die. Either that, or I'm going to prove myself wrong and I'm going to kill a VDP. So the idea will be hopefully get a working VDP, and then I'm going to melt it with 500-degree air for 3 minutes, let it cool down, show it still works, do that 5 times in a row, and show you how resilient these VDPs are. Or I'm going to do that, kill it straight away, and we've learned something new, which would be that we need to be a bit more gentle with them. So either way, we want to find out. Yes, there we go. So we've got a 2A6, which is what we want. So hopefully all these are going to be 2A6, but that's unlikely. I've only got as well... Time we want 10 to. I've got to go about 10 past 5 today, so it's just a quick stream, but it should give us plenty of time to try this new technique. And the only downside to this, I guess we could practice on this board removing a CPU, because we've got to put it on this plate. Basically, we'd have to, like I normally now hot swap these out, bit of flux, take them off here. I don't even have to take this out the board. But to do it this technique, we're going to have to not only take it out the board fully, I'm going to have to remove the screen, otherwise the screen's going to melt and smoke and smell and all kinds of things. So there's a bit more prep work. I've got a thermal camera ready as well, so we can see what's going on. I've not used this yet, I've just polished it back up. It was literally sat in the garage. I think I've got a photo on my phone because I was going to sell it. And funnily enough, right after I was going to sell it, I thought we might as well try and use it. So it's been... where's the photos? I was literally taking photos for people to buy it. like buy all the stuff I've got. Just sitting in the garage doing nothing. There we go. So that was in the garage, literally in a tub. You can barely see, but there's like a tub with all equipment that I just don't use. That was just sat on the top, and then that's what made me think, why don't we try that? It will definitely help being a bit, you know, gentler in a sense on the heat, but at the same time, I also don't believe it's anything to do with that. But like I say, I'm always willing to try new things, and at the end of the day, if it gives us more VDPs, then I'll continue to do it this way. We could even revisit the hot air temps and do slower or from the underside. You know, if we find out that temperature's got anything to do with killing VDPs, then we can rethink the process. If we get a working VDP this way and then can't kill it with heat, we can dispel that myth once and for all and be quite happy that the hot air isn't doing any damage, and I'll just probably go back to the normal, faster way of doing things, because this will be a lot slower way. So I've got to take this cage off. We've got to cut the tube off because it's just in the way. The screen we're not going to use, so I'm going to be brutal. Just rip the screen off. Sorry guys, but that's the way that's coming off. Peel the LCD off. We don't need that. And then what we want to do is we'll take off, say, this CPU. So let's move the thermal out the way a minute. I think there's a switch on the back of this thing. Afternoon, Craig. Welcome in. We've got this thing, hot air gun, fixed in position. So the idea would be preheater under here. This is an infrared tube. This should sit above, and then this would blow hot air down. So you can see you've got to get this in the perfect position to do this. So luckily we can get just far enough back. So we probably want to bring that slightly forward so you can see the setup time is a lot more. And then once that's in, you'd have to lock it in here. And I'd say that's about central there. Tighten things up, and that's now in. So not crazy amounts of work, but certainly a lot more work than just turning on your hot air and going. Now, I'm not even going to bother with this, I don't think. I think if we use infrared from underneath, this will be hot enough to remove. So, if I go on this, geez, we've got some buttons on this. Hot air is obviously hot air, so if I turn on hot air, there you go, you can hear that kick in. So that's now a hot air gun running. This thing's now running. So you could have hands free. That's going to warm up the chip. But I don't want to use that. We've got an infrared plate, which is the thing I want to use under here. And we've got an iron here. I think that's still in the garage. I haven't even brought it out. That sits here. Just a little iron. So I guess it's meant to be a kind... Oh, no way. It's the same make as the soldering iron. I never knew that. So the make of this thing I've had for years. This little Yihua. I like to think that's a Chinese Yihua. It's actually the same make as my new super cheap iron. So, yeah, that's funny. Literally everything I own now is like Chinese branded. Right, so if we're not using the iron, I can leave that off. It's quite cool that you've got an iron though, hot air and infrared plate. So all I'm going to do is turn the infrared plate on. 400, I'm going to leave it at that. So this thing will get up to 400 underneath. But what we're going to be doing is heating it up from underneath. Effectively, this would be normally used for preheating large boards that have got a lot of thermal mass. So say like Xboxes, BGA work. Then you'd swing this over, turn on the hot air, and you'd also then warm up the chip from above. It's kind of a poor man's BGA machine in a way. All I'm going to use it for is I'm going to attempt to fully remove this by just heating it from above. I'm not even going to attempt hot air. I'm going to try pure infrared soldering at this point. So let's zoom in and see if we can get a decent shot here. Yeah, decent-ish. It's kind of not focusing where I want, but yeah, it's not really focusing on that area. But you can see where it is now. So if I go to the overhead, maybe I can just drag this down instead. Oh, there we go. That's a better view. Pull focus. There we go. So this is now got... I can swing back to that a minute and zoom out so you can see the thermal. So what we'll do first is, we should see, like, yeah, I can feel that's getting warm already. We can use this to see, I guess, the temperature of this and the rough temperature of the board to give us some gauge of what we're doing and how long things take. What board is this? This is a Game Gear, so we've got multiple Game Gears here. The goal is to remove these ASICs a bit more gently than with hot air to see if the hot air technique has anything to do with damaging the chips or not. And if we look now, this has got a preheat, so if you can see at the front, I don't think you quite can, front of this thing now, it's at 160, so this has got to climb up to, I think we've got it set to 400. So obviously you normally wouldn't necessarily put this board on here. You'd wait for the infrared to get hot enough and then put your board in place. So this is going to be a bit of a cheat in terms of time, because this board is going to be on sooner than that. But while we're waiting, let's unscrew another board, and then what we can do is, if we get the timings right, we will put another chip on. The idea is try and get it so we've got, similar to the hot air, a known kind of perfect timing. Just drop a Game Gear on, wait X amount of time, and then lift the chip off. A good thing on this as well, let's put some flux on, because that will give us a good indicator when the flux starts bubbling of whereabouts we're at in the process. Right, so it's up to 220 at the minute. And the first one's just going to be me getting a feel for this machine, like if it's even going to work. I'm not going to time anything for now, I just want to see what's going on. What we're modding, we are transferring, well, we're removing chips from Game Gears at the minute. And I have in the background, we've got two white PCBs with a questionable CPU on that one. This one has got very lightly a known fully working Game Gear except the VDP, and unfortunately we've got a bad VDP there. The only other one we had yesterday was also a bad VDP, so we're trying to get a VDP off a Game Gear working, and then once we've got a working one, I'm going to try and kill it. Let's see how resilient they are, which I really shouldn't, because we need every VDP we can get, but in the name of science, I need to know. Basically, I want to know how durable they are. Once we know that, then we can change technique if it turns out heat really is a killer of them. That's that one out of the case. And then same again for this. Let's see where we're at actually with this while we're talking away. Is this thing even warm? Yeah, so that's now over 210, which is this thermal camera's limit. So we just know the infrared is obviously... can I get it on camera there? Wow, this is an awkward angle. Trust me, that says over 210 anyway. There we go, you guys can just about see over 210. And the PCB that we're interested in is at 140. So you can see that that's starting to work. That's going to have to get up to 200 before anything happens. So we've got a little while yet, I think. But yeah, this, you can see the strip down is a bit more intense. I've got to take apart the console a bit more. But I don't mind doing this if it, you know, literally saves us on murdering VDPs, we'll see. Well, I'm going to say my gut is telling me that it's not the heat killing them, and it's just the fact that obviously, oh, we've got some smoke coming off now, so we're getting somewhere close. My gut's telling me that it's just the fact that we brought a ton of Game Gears that some other guy couldn't fix. That's the ones we've been working through the whole time on streams. There's like 100 Game Gears that I brought that a guy couldn't fix. Now these ones are off eBay, I reckon we'll have much more consistent results. Right, that's at 140, and we've got some smoke. So the flux is starting to smoke at 140. The infrared's only at 360 yet, it's not at the 400, which I think it should be set to. Yeah, 176, so takes its time, but I think once the infrared's preheated, I don't think we'll be anywhere near this long to warm up. And like I say, normally at this point, you'd swing this over hot air and take it off quite quick. I'm going to purposely leave just nothing but infrared and try to do this entire process, not only taking the chip off, but putting the new one on. We're going to try completely soldering iron and hot air free soldering, except the fact we have to use a soldering iron to tin the pads. Right, so that's another one ready, and I think we better get ready with this because this is looking like we might be somewhere like. So, see all that lovely smoke? We are at 171, yeah, so it's slowly climbing. I think we've got a little while yet. Yeah, holiday hair for sure. It's also, I've just been shopping for a few clothes, so I've been trying on hoodies over and over, so my hair's kind of gone flat, but it was a bit more styled. Right, 195, there we go, so this is heating up. Well, actually no, the chip is actually the coolest part, which is good. So if you see over here, if I pull focus up to the camera, without melting my camera, can't quite pull it focused enough, but see how the chip is black, that's like cold, like dark red, but the board around it is over 200. That's what we want. So basically, that means the chip is colder, but I presume this is probably even ready to go. Not quite. So the board is warmer than the chip, which is what you want. You're keeping the chip as cool as you can in terms of removing it. So I don't think this is going to show us much more other than when we're up to temp, which this is at now. You can see there on the blurry camera, we're coming up to 182. It's now up to 400 degrees, so the infrared is at 400. Yeah, fume extractor, this is actually going up and out my face. This isn't even going into my face at the minute. And then the purifier behind will kick in. If this works, I might even get like a decent station, like a proper one with a thermal camera built in and all kinds of stuff. It'd be quite cool. I'm YouTube featured today. What's that mean? Like they're pushing it or promoting it or something. I'll answer the questions in a sec as well. I just want to kind of keep an eye on this. Yeah, so you can see there now, everything's above 200. Although the chip's sitting at 191, the PCB is coming up to the 200. So, are we now loose? Nope, not yet. But a little bit of time. Is there a way to get new PCBs made that accept ribbons for game cartridges that come with more modern battery? Yeah, that's literally what we have. So that's what you're about to see be made, and that's what we sell. So this thing right here, modern cartridge connector. This is called the game slot that we sell, and I've made. This is a re-PCB, which is the whole game gear. These are the chips that you put on, and everything else is new. Modern screen, modern cartridge connector. This is literally our Prestige Retro 6 game gear. So it's exactly what you're after. Right, overhead, we can't be far off now, if this is even going to work. So, still not loose. I reckon maybe then, a bit of hot air, do you think? Gentle hot air. Oh, nice, yeah, so we might see more YouTube. Of course, when I've only got like an hour, YouTube decide to feature it. You need the chips, but we also sell them fully assembled. So if you go on the website and look for re-PCB, R-E-P-C-B, you can buy it fully done. You can even buy the entire console done. You don't need anything. There's literally do-it-yourself boards, there's do-it-yourself mods, there's send in your own game gear, or there's buy one fully built. There's literally every version. No, so I think this is going to need... I was really hopeful this would... I wonder if we can go higher. No, so maxed out. So this is 400C, we can't go any higher. I'm kind of bored waiting for it to warm up anymore. I wanted to do it entirely infrared. I think it will. Tell you what, a bit more flux maybe. If not, I could get it off. We'd have to go closer, which means maybe custom rails to get this lower to the infrared. I mean, that is hot. I can see bubbling. I presume you guys maybe can. Let me zoom in a bit. You see, there's that air purifier kicking in. I'll show you that. So, see the solder bubbling here? So I think we are. I think, ooh, that's a lot of smoke. Let me sit back. That's look at this. This is the sign it's about to come off, to be honest. So I think we're going to get there. That's definitely going to go. See all the bubbling? That's the flux bubbling. That's right when we're about to lift, I reckon. Are we free? I wonder if this is free, you know, and that's... it might be the assembly glue underneath. I bet this has been free for ages. No, that's... oh, yeah. It's been loose for ages, I think. I think that's... No, it doesn't look... The traces are lifting off there, I think. Yeah, no, that's not come off at all. So, we can't quite infrared it fully. But, we could do this. Put the hot air on, say at 300C. So now, we've preheated the board. And then this is only 300, you know, we work at 480. So the temperature over the chip is much lower at the minute. And let's see if this warms up enough. So, didn't quite come off with just infrared. We'll try on the next one maybe. See if it does, because I still hold hope that it would. Oh yeah, I'm keeping well away from that smoke. But I've got a little fan that can blow it out the way and an air purifier behind me. I don't know whether this is actually stuck to the board in some odd fashion that I've never seen. Because that's completely free there, but this is like it's stuck here. Not sure why. Like this end seems stuck to me. See how it's like lifting with the... Look, that's entirely off, but I think this is actually a problem here. Like, let me move that out of the way. I think that would have worked when we have incredibly bad luck that this chip is in some strange way bonded to this board, because look, it's doesn't want to come off. Like, that to me, I think if we do that again, I think that would have worked. I think something strange has got on there with that board, that chip sticking to the board. So yeah, it's also, I can grab it from here and it's not too hot. So let me move him out of the way a minute. Oh, look at that as well, actually. There's a sign. Let me go overhead. This is kind of hope for us that the infrared would have worked. There's the crystal. Crystal just lifts out. So it was melting. I think that chip was just literally stuck to the board. Let's try it again. Ooh. That's the flux drip through and like kind of melted a hole into the infrared. Yeah, God knows. Maybe flux isn't a good idea then. Let's leave the flux off. We've got 400 degree infrared already, so I'm just going to do this again and completely ignore the first test. Let's put this over here, kind of bolt that in if I can, and this is like a cheapish machine. Let's set a timer off now. Yep, we ship worldwide, so we ship to the US as well. Clock, stopwatch, start. Right, so we've got a stopwatch. Where's this going to go without melting? There we go. It's going to take at least a few minutes. I'm not going to use flux because that seems to have, I don't know, that's like damaged the infrared underneath. Maybe that's why it's not worked, but we'll see. Do I fix other bits of tech? Yeah, we fix, well, we fix all retro stuff at the minute, and we're too busy really to take on too many other things that aren't retro. But yeah, we generally fix, you know, most things. Repairing automotive ECUs, no. I mean, I'd like to, but again, we're too busy really for doing that. I did used to try and, well, I didn't try, I did have all the tools to flash. When I had like a Jeep SRT, I flashed a custom ECU from the States, funnily enough. They obviously mod them a lot more than we do. I flashed custom code onto that, nearly blew the engine up, but yeah. Yeah, with these drinks, the thing is, I love the look of them. I buy stuff by appearance, and they look ace. And I brought 12 or 24 of them. They were absolutely disgusting. By the time I got to, say, the 11th can out of 12, I thought, oh, these aren't too bad. Brought another 12, waited 3 days until they come. In those 3 days, my taste buds realised they were gross again, and then when I grabbed another can, I was like, oh, it's disgusting. So now I've kind of, it's almost like a punishment that I've got to drink them because I keep buying them. But I just love the cans. I just think they look ace. And obviously they're healthy because they're practically just all water. Yeah, this is like definitely a slower method of doing this job. I'll tell you what, we'll try the crystal. I think if the crystal comes loose, like if we can lift this crystal out, basically. Is that focus there? Yeah, we're in focus already. Zoom out a little bit. I'm going to take it that if it can melt the crystal, then it'll get hot enough to remove the chips. And I think that chip sticking there was, honestly, I just think that was a one-off. So let's give it, I think it'd take at least probably 3 or 4 minutes maybe to warm up, because it's got to heat the whole board from underneath. But I do think this is going to work. If not, then it's obviously a blast of the hot air gun as well. But we're trying to keep the heat as low as possible, basically, on this. That's the goal. Yeah, all the ones all the drinks I've found alike are not exactly good. Like they've either got calories in, extra sugar in. Trying to find just a nice flavoured water that's actually healthy seems difficult. Yeah, I don't think this is I don't know that I could wait this long. I think what we do is, I don't know, why do I want to feel like this is going to work? Can we put this board lower? We could, but how do we do that? Do I just put the board straight on the infrared? Is that bad? I think we do that. Sod this bracket off. Sorry, Game Gear. Onto the fire you go. Ah, this is going to come off, because I've just basically plonked it straight onto the infrared panel. And this will still be colder than using hot air from above, but I'd say this is going to get the chip off. Unless I've killed the thing, because there's that burny thing. I don't know whether I've kind of killed the infrared panel in that spot or not. I don't think I would have. It's just been going 4 minutes 18 seconds. Do I do a clean power for the Wii? No, unfortunately I don't really work on the Wii, so no, unfortunately. Essence from Iceland. Nice, I'll try it. In fact, yeah, no, I haven't had that. I was going to say I think the name rings a bell, but it doesn't. Oh, there you go. Da-da! VDP is off. CPU isn't yet, but VDP is off. Is the crystal ready? Crystal's off. Look at that. Hey, I like this. Silent soldering. So that's at 5 minutes. We're going to stop that and we'll do a third one straight on this thing. Oh yeah, there you go. CPU. This is sick. I like this. No flux, no mess, no noise, no smoke. I better get this thing off. It's smoking. Yeah, the underside of the board. I don't know whether to tip this upside down if shit's going to fall off. It hasn't even done damage either. Hey, I've got a new favourite. Oh shit. Stuff hasn't fell out and everything falls out. I was just about to say I've got a new favourite thing, and then a fuck ton of components have just all fell into the machine. Right then. Oh shit. Melting my controller as well. Yeah, I'm just like placing hot things. Oh, for fuck's sake, yeah. Bear in mind I need to pay attention a bit more. I'm just placing boiling hot PCBs over all my expensive stuff. Right, so we know it works. The problem there is, I've got a whiteboard I don't mind destroying. Yes, I have. Where's my white PCB? There we go. I knew I kept this for a reason. So, the next thing is, if we're going to solder this back on, if we're placing this board straight over here, is this now not going to char the white PCB? So basically we've just got this PCB completely flat on this grill. Let's leave that for, get the timer back out. I'm going to leave that for 4 minutes, so let's get a timer back on the go. Before I even attempt to solder, I want to see if that's going to burn this board, because if it is, we're not going to be able to solder back on. But we can get the chips off this way, so that's one thing. And the chips I could do with, because the thermal camera only goes up to 210, I could do with the infrared probe thing, which I don't know where it is, and I can't be bothered to get at the minute. You could probe it for higher than 200 degrees. So if this works, I'll kind of do it a bit more structured than me just messing around and, you know, this is just me having a quick go, see if it works. I'll get like a proper temperature probe that can measure the temperature, see what temperature the chip gets up to, compare that to hot air, you know, do a bit more of a scientific test than a Luke can't be arsed on a Saturday test. But so far it looks promising. We've now just got to prove if this board's going to melt or not, or burn, and then it's no good. If this survives, then we can have a go at soldering the VDP back on. Oh yeah, I know that dude. Yeah, I haven't seen him floating around in a while, but yeah, I know that meme. Lynx Clean Power battery the clean power is just AA batteries. You don't actually recharge them. If you put the USB-C port in, then it'll get noise. Oh, this thing's smoking. Let's check if he's burnt yet. Nope, he's survived. Smells burny. Smells very smells very burny, but he hasn't burnt yet. Yeah, so the USB port on the Lynx Clean Power, you want a clean power supply, otherwise you'll get noise. I'm going to work on figuring out a way that you can still use dirty USB power supplies and not get noise, but until then, go with Anchor, the Anchor power supply, basically. Right, 2 minutes in. To be honest, how this is smoking, I'd say a chip would probably melt on there, or solder would. It's hard to tell because I put no solder on like a ball end. I decided to not do this test very accurately. I should probably put a bit of solder on there and see if the solder starts melting, maybe. This is cool. It's a weird way of soldering though. No noise and just sitting waiting. Tell you what, this might be a new favourite thing. Even pre-tinning, no flux, work perfect. Let me show you that again. So with the board being super hot, obviously. Full focus there. So yeah, watch this. No flux. Solder. Look at that. That's sick. Just literally no flux. Oh, of course that screwed it up. That looked ace until I did that. But yeah, that's definitely that is flowing better. Obviously it will do. The board's stonking hot. It's kind of obvious, but yeah, that flowed well. So I think that solder is definitely molten. Yeah, look, I can drag through it. This is going to work then, I think. So I guess let's see if... Woo, that board's getting toasty. Yeah, it's getting hot. Perfectly fine. So no, just ignore the mess. That's just this gunk. That's flux. The board isn't burnt at all. And that's 3 minutes 38. I can't be bothered to wait. That's clearly going to survive. So we're onto something here. We are definitely onto something. Right then, what's next? All you have to remember is when these are done, I keep placing them. You can hold them here, but there's boiling. You have to remember to place it down somewhere and not touch it. Right, let's go for... And again, this is a pain because you have to remove stuff. So I'm going to have to remove the ribbons and the screen. And the cartridge connector. I suppose it's not that bad, but... that's out the way. So this has got a bad VDP. So we're going to place him on here. Oh, I wonder if that's going to melt. Headphone port. Let's try and place him like that. So kind of on there, but not quite on there. There we go. Oh. Under there. It's a good job this board is shaped the way it is, because the crystal doesn't go under. Damn you, crystal. This way. There we go. Haha. There. Right, that's one way of doing it. So now we've got the chips as close as we can to the board. We can now drag this. Is going to fall off my desk. I keep pulling it further and further to get on this camera, and it's hanging off my desk. They are the VDP and CPU. We want to get the VDP off. I'm not going to use flux yet. Time-wise, I should start a timer now. So, clear, start. So we want to see if this comes off, how long it takes, and then we'll put another one back on. Oh yeah, the lives, I can't hide the fact that stuff goes wrong. So yeah, you'll hear me swearing every now and then. Right, this is only 30 seconds in and we've got steam already. Nope, so not off. And what else can we do while we wait? Nothing really, I guess. How come some of the pads are taller on the CPU footprints? That was just how Sega did it originally on the original green one that I copied off. So you can see the pads are bigger. But I think I know the reason why. Because when I drag solder these, obviously mine don't have that, but when you drag solder on the original, you tend to have a ball as you're dragging down of solder that at the end you then have to get off. And what I found was happening is when you drag solder down on the green, the pad at the end catches all that excess solder. So maybe Sega knew more about drag soldering back then. And 1 minute 30, not off. And I think they did it so that if they were hand assembling them, I doubt they were, but maybe at the start for prototyping they were, when you drag solder down, maybe it was for catching that excess solder. That's me guess, basically. Yeah, this is definitely this is definitely the start of how we made fire. Somebody did this originally and got something too hot and then saw smoke. I don't know what the smoke even is. Maybe residual flux. Maybe the inner PCB layers. I don't know. This PCB is a Game Gear, so it's a board I've made. Right, we're at 2 minutes 10. Yes, look at that. And the beauty of this, 2 minutes 10. So that took just over 2 minutes to get off. We just turn this around. All the pins are straight because we've lifted it off with it. This will be the key. Plonk you on. And they're already going to be molten. They won't have even cooled because they're still under heat. Oh, so it's actually cool because I've put the chip on. So let's give that another, I don't know, minute. And then let's nudge him in position. But yeah, this is actually not a bad technique. Still solidified at the minute. The only thing is, this one will be in a nice little reflow, because obviously he's there as well. Yes, go on, get on. And then at this stage we're going to have to use flux, so flux on we go. Smoke's going to go everywhere, but this chip is not going to reflow if we don't put flux on. So is this now, people that don't want to solder at all can do this. The thing is, it's hard to see at this angle. I'd like to try and... Oh yeah, it's literally working. That's crazy. That actually works. Yeah, look at that. It's literally reflowing perfect. That's reflowing just like when you use the hot air. And then I could maybe push down. Yep, it's gone solid again, so let's give him... He's been on now 1.5 minutes since we took him off. And it's been on the board 4 minutes total. And like I say, we might be burning the board underneath at this time, we don't really know, but that's what we're here to find out. I think I'd be tempted to use the hot air just to speed this up. But for the first one, let's use pure infrared, just so we can do what the title said and it's not clickbait. I think we're good. That's bubbling away quite happily. I think all them pins are on nice. Moves around fully now, so it's fully hot, so we're good there. Problem is, how the fuck do I get this off? Because I held it here and wedged it under there and the crystal's too tall. Yeah, shit. Let's move this back. Let's grab this end. Is he hot? We're okay. Move him over here. I need thermal gloves. Whew, look how red my face is from the infrared as well. I'm getting a suntan. Grab you. Drag slowly. And I'm probably going to skittle all these chips doing this. Yeah, we need to rethink my Jenga setup, but... Come on. Hot things. There we go. I don't know where I'm going to go with this, though. We're free. Right. Where do I place other hot thing? Ow, ow. There we go. Right, get that away from my face, that's boiling. So, principle is proven. Yeah, I could have just turned the machine off. Not a bad idea. I think it was more fun this way. I think we've proven that we can get a VDP on with nothing but infrared, but I think we'd want hot air as well. That took 6 minutes as opposed to about 30 seconds with hot air. So unless this proves it's going to make a world of difference, that is a hell of a lot slower process. And a lot more. I'm sure I could perfect the process a bit more. Obviously, very first go of anything takes a lot more time and energy. We want to probably, can I do maybe move this? I kind of want to keep that preheated in case we do this again, but it's in my way. Ow, the machine's hot as well. Everything's freaking hot. Yeah, this is being passed off to Zach if this works anyway. I don't have to do it then. Let's have a look at this. So, under the scope, that is done. That's done a perfect job. Like, literally perfect. Did we burn anything though? Either that's old flux or we burnt the board. I think it's just old flux though. Is that brown? Let's see. Yes, indestructible whiteboard wins again. Just flux. So it's done a really, really good job. Like, I don't think it's quite as good as my hot airing, just because, I don't know, maybe it's better to be honest, but just looks like a tiny bit dry jointy maybe, but maybe I'm being a bit of a perfectionist in terms of the solder balls, but that's soldered good. So that's definitely worked. Whether it's done any different, I guess the proof is if this happens to be a bad VDP as well, there goes the whole heat theory straight out the window anyway, because if this is still dead, it's clearly nothing to do with heat and it's just more luck, because that is probably the slowest temperature you could ever transfer any electronic component with solder, personally. I don't think we could have put the chip under less thermal stress if we tried. All the other chips seem to have survived as well, and the board's stone cold already, so I think that means we're ready to see if this works, I think. Now, the other concern people have had is using this cable, is it killing the VDP? Because it's not, people either think this isn't regulated, which it is. USB has to be regulated. There's literally a USB organisation that say you have to regulate the 5 volt. But there's a concern that people actually think, is this regulated enough and, you know, doing damage? So we can plug it into this board, and then we can get the scope up and see what my USB power brick I've been doing this all along with is actually outputting. I tell you what, that infrared though, I feel like I've got a suntan. My face is burning up from it. It's like radiating over here. Let me just, actually, shouldn't be soldering with ground attached. Right, that's on there. Pull up the... I need to keep an eye on time as well, but just guys let me know when it's like 5 o'clock, because I'm not even paying attention to time and then I'll forget and get in trouble. Solder bridge on the bottom of the VDP, I'll have a look in a minute. Right, so when you're testing power supplies, you're really not meant to do this. So see the big massive ground loop, so ground here all the way up through the probe, testing 5 volts say over here, and you've got this massive ground loop. So this will give us more noise on the 5 volt than you would actually see. What you should really do is probe like how we have over here. We have ground and 5 volts here. We should realistically probe here and here with the oscilloscope, and it gives you a more closed loop. I'm going to purposely make the big long ground loop so we can see the worst case scenario of this 5 volt power. Like, this is as bad as it would ever be, and it's not really super accurate. It's going to purposely show it even worse than it is. So this is under load. This is literally loaded up. If we go on the 5 volts, there's this 5 volt power supply. So you can see there's quite a bit of ripple on there. Let's have a look at the measurement. Amplitude. You can see we've got 300. We can also go slower, and it's more averaged out, or faster, and you can see the actual ripples here. So there's the main pulse that's giving us a ripple. So it's between 200 and 300 millivolts of ripple on there, which is also, if we look at where the 5 volt line is, there's 5 volt and the ripple's perfectly around it. So it's a 5 volt regulated power supply with a decent amount of ripple. But if you know how to measure these things, you don't measure power ripple above 20 megahertz. The theory is, and it's not by me, it's by smarter people with PhDs and things, you measure ripple with a 20 megahertz filter on, because ICs don't typically see very high and short bursts of pulses and frequencies. So this is a raw measurement, but a realistic accurate measurement is putting a 20 megahertz filter on, and you can see that drops it significantly. You could also go to AC mode, lower the voltage down to really boost up the noise if you wanted to see what it was made of, zoom in, and there's your kind of high voltage peaks. So these peaks are the USB regulating. These are like when the voltage drops, it boosts, drops, boosts. This is normal for all switching power supplies, and our clean powers are typically like 12 to 40 millivolts. This is 200, so realistically it's like a 200 millivolt. So not the cleanest, and that's what some people think might be doing damage as well. I don't think that, but again, to eliminate all of these potential problems in one go, we're also not going to use the USB port for now. We're going to use a where are we? A new power core. And this thing, oh, this is a prototype, but so long as it's not, I don't think I changed the design or improved anything. Let's see what, actually, I don't know whether this is going to pass through the same 5 volts or not. I've closed down the oscilloscope, 1 second. We'll use basically a power core, which is obviously known to work on consoles, and we've sold, I think, nearly 1,000 already as well, so we know these things work and they don't kill anything. And yeah, that's basically a pass-through on the USB there. So if we use then instead a clean juice, this will be probably the best. Obviously the clean juice is more expensive, but this is designed to be the best power you can get. Let's see, and again, bear in mind I have this massive wire on. Yeah, so to be honest, the wire is causing most of this noise, because the clean juice I know is tiny in terms of ripple, and you can see there it's showing measurement, peak to peak, amplitude rather we want, yeah, amplitude's on there. Bring that up, delete. You can see this is showing like 100. I know this is a lot less. So this is where, see this giant loop here that I mentioned? If we now disconnect this, and instead we have, say, a tiny wire attached to this ground point. So let's get, have we got a resistor or something? Just want a metal leg. We'll use one of these. We'll just measure slightly different. And we'll basically measure with a smaller loop, and you'll see how much difference that makes to the apparent noise on the circuit. And if you don't know how to measure this, then that's why. You can very easily get false readings when you think you're measuring stuff right. And what you're meant to do is you can actually get a probe where you take this off completely, and this is a baby spring that clips on here, so you can actually attach a ground clip from here to here, like a very small probe, and that's how you're meant to measure ripple. So this is still classed as a big ground loop, but for the purposes of this test, I'll show you how much difference that makes. If we have power on there, that on there, turn on, and there you go. So there's basically, you can't even see the ripple there. We go in, put the 20 megs on, AC, and you can see that's now dropped it to 84 from 300, and that's just literally reducing this wire. So if we reduce this wire even further and soldered on from here to here, and I've done this test before, I know the clean just gives us like 40 milliamps. So let's go back to the USB straight in, the thing we were concerned about. So I'm just going to plug the USB straight into here. Oh, he says, as he nearly rips the clean screen off because it's stuck to the mat. Let me connect him back up, and we'll remeasure that ripple on the USB. And bear in mind, this was, what did we say, 300 millivolt ripple, and nothing's changed. We're powering it up with the same cable. And now if we measure there, press play, let's see if it's improved. So there you go, that's actually as low as the clean juice. So now if I was to show you that we're not doing anything different, we have the USB straight in, a shortish loop there. If we now measure the ripple, you can see literally perfect. So this power supply, when you're measuring it correctly, is perfectly fine. It's got 4.99 volts, and it's got less than 70 millivolts of ripple. So that can dispel the myth that this is doing damage. That's a super clean USB. But it can also show, if you don't know how to test, when we were testing over here on this loop, which we can do again, just to show you, if you don't know how to test, you can think there's more problems than there are. So if we then go on there with a big ground loop, and you can see it's gone up to the 200 again. So if we go closer, oh, where am I going with this? Go to AC, come down, and you've got like 100. So even just reconnecting this has improved it. So that's 140, and I'll do it straight on, ungrip this, grip it onto that closer point, and there you go, 50. So all I'm doing, 50 millivolt ripple, grip off, grip onto this over here, and you magically have way more ripple. So it's all just about knowing how to measure. But long story short, this is as clean as the clean juice, which we've sold for 6 years now, and as clean as the power core. So we know my USB test is definitely not the problem, basically. So we'll go ahead and power this up with, well, we'll keep the test fair. We'll still power it up with the clean juice, ignoring the fact that we know the USB isn't a problem. And now what we've done is we have a VDP we just transferred over on the lowest possible temperature using infrared only, no hot air, the chip's not even been directly under any heat, and We've got it on the board ready to test. We're going to power up without the USB as well, because that's another potential cause of a problem. This is the one we're hoping works, so now we've got to put the screen on. I need to put a power ribbon on, because it doesn't even have one on at the minute. And then this is the most gentle way we could have possibly put this chip on. And then, like I say, hopefully this is going to work, and then we're going to see what it takes to kill this VDP. That bottom of the VDP I haven't forgotten as well. We'll take a quick look at that in a second. If you think there was a short on. There are pins on the VDP that are meant to be shorted, by the way. So it could be that. That's the connector on. So let's take a quick look over here. I'll tell you what, this infrared heater's killing me. It's literally burning my face up, and it's sat over there. Right, where did you see the join, or you thought you saw the join? Because I didn't even see one at all, to be honest, but I know there are pins that are technically joined. I can't remember which. I think it's the CPU technically that has pins that are joined, but I don't see any join pins there. Give up watching the Veil. Yeah, I don't blame you. What solder am I using for the chip? I use, at the minute, Soldering. It's basically a 60% lead, 40% tin, I think, with a few little bits in. I don't use low melt solder. I own some, but I don't use some. So I think then we are ready to test this. I can't see shorts on there. If anybody else did, just shout up. We'll put the screen in now then. And I think this is the one that had everything working, Sega loading, but clear signs of a bad VDP. So if nothing else has changed, this should boot up, we should hear Sonic, and hopefully, if it's come off right and it's a working VDP, this will also work. I hope it does, because then, like I say, we get to kill it, and I've only got like 15-20 minutes to try and kill it. It's a shame, because like I say, we really need these chips for customers, but I want to see what's killing the chips. If it's anything other than just bad luck. Audio. So you can see we've not used our potentially dangerous USB that people think might be dangerous. We've not used hot air and hot temps. There's no solder shorts, and everything on this board was working except the VDP. This is also a Game Gear from eBay, so not one of me stock from another guy. Like every other one we've had is literally from one person, so I could have been given almost a purposeful batch of known bad VDPs, but that doesn't really matter. So let's see. Wicked. Nothing. Yay, so it was working, doesn't work at all. So, what do you make of that? Because that's not widescreen. Oh, you know what? Games. You need games for things to load. Let's hope for me yet. Right then, here we go. Yes, working VDP. Now let's kill it. Right, let's turn this infrared hot plate off so I don't melt. Right, so good VDP, great start. Now we try to kill this thing. So let's finish with either this thing survives everything and we prove that it's not weak, or we find out what we've potentially been doing wrong to kill these things. First thing we can do, unplug the clean juice, plug in the USB test lead. So this is the thing that people think might kill it. Let's see. Still good. How many times do you reckon? I mean, this is about as unstable as you can get with power. Hot plug in a USB. reset. Unplug, plug in. So, obviously ridiculously unscientific test, but I don't think the USB is going to kill them. I test all the Game Gears this way. I highly doubt the USB is a problem. That's just one of the concerns people have. That's like probably the least concern. People think it might be the USB. We've seen on the oscilloscope this thing is as clean as the clean juice, so there's no realistic purpose or point to this thinking this is going to be a problem. Like if you've tested it, there's literally no logical reason whatsoever this would damage it, and it obviously doesn't appear to be. The main other thing is heat, pretty much. Well, there's two things. One was if that USB was bad and it overvolts it. I could overvolt this chip, which I don't think will kill it. I've got one running at 5.5 volts now, so we could easily tweak this and put 5.5 volts to it and run it. Maybe that's for another day. I jack one up at 5.5 volts and leave it running for days or permanently until it dies. But the other main concern was the way I swap these off. Hot airing them off at 480 degrees and back on. So, now we know that, you can have a guess what I'm going to do. I'm going to hot air this thing on and off and on and off and on and off until I have to go. And let's prove that hot air does not kill these things. Or that it does, and we need to be careful. So, hot air, 480 degrees. Well, you saw it there. You'll see it get up to 480, so you know I'm on the line. And then I'll take this off, put it back on, let it cool, turn it on. I'm going to do that over and over until I leave. I think you'd agree then, if I can do this, at least 4, 5, 6 times, can we then agree that hot air and this technique is not killing it, and it's just purely the Game Gears I've been getting have been having bad VDPs and there's nothing else to it, basically, which is my presumption all along, but I do like to test things because you can be wrong, and arrogance is the main reason people don't learn. If I was too arrogant and thinking it couldn't be that, and I don't test it, I could sit here, kill loads of VDPs for no reason, and these things are obviously 40, 50 pounds a pop. Every time one doesn't work, I've lost 50 quid, so I'd want to be proven wrong as much as anybody else. But I don't think I will be, basically. I think it's just exactly what I thought it was, is that we do more Game Gears than most people do. We do, well, I've got through that batch of 100 from that guy in about 3 or 4 weeks. It's just that we see loads of VDPs, and you guys obviously don't see all the Game Gears going out, but you'll see the ones I do on stream, and I think it's just bad luck and a bad batch, basically. I don't think there's anything magical going on, but like I say, I could take this off now and kill the VDP, and then we know I literally am killing them. So one way or the other, we'll find out, and at least I'll have confidence that I'm not killing it if I can take this on and off multiple times. And it not, I didn't use any flux, did I? I should probably use a bit of flux. You know, I can be confident that I'm not killing them by mistake, basically. Bit of flux on there. I mean, do I take it on and off loads, or do I just sit here and warm it up an absolute ton? Like, there's two options. I'll remove it and put it back on, and then if that's off, we could clean that flux under there while we're here, I guess, just for the sake. Get this chip back on, like we're just transferring over. It's my usual alignment skills. This is about as aligned as you get it. Sorry, there we go. That's good enough for me again. Do exactly what I would do. Plenty of flux, plenty of hot air, and this hasn't even had a break. This has come straight off, straight back on. So, yeah, I think we will as well. We'll do the standard first, just literally a hot swap. So acting like I've just literally put this thing on the normal way. If it survives that, I'll maybe do it once more just to prove it definitely isn't the heat, you know, taking it on and off when in short succession. If that doesn't kill it, we'll really, really overheat this thing on the bench and see if it still survives. If it survives a bench purposeful overheat, we know it's not temperature, basically. So, I think you'll all agree that's about as much heat as I use when I'm doing it. Nice and close with the hot air. Good clean with the static infused melamine sponge, which could also be a potential that nobody mentioned, that this melamine sponge is probably staticky. But again, we're doing everything the way we would have done. And now we just let that cool and see if the VDP's been killed. I hope it hasn't, because that means I've probably killed a ton of them in the last month, if this is a process that does kill them. But I'll also be happy if we've discovered something new. So we'll see. Yeah, the other fun thing is, if it is bond wires inside, we can repair them. And I've got plenty of bad VDPs. I can grind one down and find the exact positions you typically have the pads. And I could also oscilloscope probe the whole chip, because they all seem to die almost identical. The most common death, if I show you, of the VDP is always, well, very often, one specific visual failure. So if it is going to fail a certain way, maybe that's just how it fails, basically. That's just, if something fails, the whole thing looks like that. But if I just pull up, it's like an advert for you. I'm not sponsored, honestly. And I don't want to be sponsored. I don't want to drink any more of them. Pull this up. So if I scroll down on here, that's the most common one there. So see these slightly diagonal lines here, and bear in mind this is upside down screen. Those two diagonal lines and then random data. This is almost what it always looks like. So you always have these kind of two diagonal lines. The data's different, but that is something I see very often. So that's what makes me think, if there is a failure that's semi-common, we might be able to find a cause. Right, that's cool enough. Let's power up. You watch, I'll laugh if this has killed it. No way. So yeah, heat is killing it. So it's just purely the hot air. Wow, so I've been destroying these chips. Or melamine sponge. That's the other thing we could have done. So what we'd have to do next is, yeah, that's crazy. So heat is killing the VDPs. And yet I've had it where, well, I don't know, it could be the sponge, because I've hot aired VDPs on and off that work when I'm using a board to test if it works, and taking them on and off multiple times. So we could be down to the melamine sponge could be killing it, or the hot air could be killing it. That's crazy, didn't expect that. So that would mean, well, I don't know, it's one test. Heat is obviously, heat or this is a problem. Or, yeah, it could just be the heat that we've done it multiple times, but that's fairly conclusive that literally a working VDP, hot aired off, has likely killed it, and that's, I've done that exactly as I would, which is 480 degrees Celsius, hot airing it on and off. So we could still hot air it. We likely just want to lower the temperature down and try that, but that's a shame. That means I've probably killed quite a few VDPs. I am now the VDP killer. We can't blame the VDPs for being shit, it's me just killing them. Yeah, 6 minutes. I've probably got 10 minutes overlap, so we can do like 17 minutes. Right, so where does that leave us? Because I don't really want to use this, although that's quite cool. Most people won't have one of them. I still want to hot air it, but that does mean they're quite sensitive to heat then. Or like I say, I didn't clean it with the sponge, which probably should be the next test. We should probably, I should have probably done that first, but I didn't expect it. We could infrared swap another VDP on, then clean it with the melamine sponge in case this is killing it. This might be generating static and killing it. Might be nothing to do with heat. So, can we get, I don't think we're going to get a, I've just turned this off as well. I don't think we're going to get another VDP swap in 7 minutes and tested. But let's start. Let's see where we get. But yeah, that's a discovery. So if you're following my guides at the minute, just be careful because it's either the hot air killing it or the melamine sponge killing it, or we're just incredibly bad luck there, which I doubt. I think it is literally. It does look like these VDPs are sensitive to heat, which is the first time I think I've ever known heat to kill a chip. That's why I'm kind of thinking it's the melamine sponge. So let's see. We need to. I can hot air this chip off because we don't need the. We literally don't need to be careful with this now. It's dead. So let me just hot air this VDP off, and then we will get another Game Gear. Wow! So I've been destroying Game Gears. I need a new hoodie. VDP killer. The VDP Ripper. But that's the benefit of also listening to people that obviously telling you could be doing something wrong, instead of getting arsey and think you know more than they do. You can have your presumptions that I highly doubted it was going to be heat. Like I say, I've never killed a chip hot airing it on and off before. But also you should listen to them and test the theories out to prove you or them right. So it's done us good that people have suspected why we're getting so many bad VDPs and nobody else's. I presumed it was just a batch from this one person that couldn't fix them, and a load of bad VDPs and bad luck, because historically with all my work I've never killed chips using hot air. So that's my presumption for why I figured I was right. It made logical sense, but obviously I think by the looks of this test that was completely wrong. We are killing them with air, maybe. Yeah, start a rap group for sure. Well, this is good news though, because that means we now know what's killing the chips, and we can hopefully prevent this. That is proper. I did not expect that result, so good, but quite shocked at that. I'm wondering, like I say, whether it's this melamine sponge now. But again, why if it was a sponge or air, nothing else ever dies? The CPU never dies. The Z80 never dies. Why is this thing not coming off? Oh, because I've got it on a big metal plate absorbing all the heat. This normally takes seconds and it's taking forever to come off. The VDP must just be more susceptible in general to whatever causes it to die, whereas the CPU and Z80 obviously aren't that sensitive. Right, that's the dead dead VDP off. I've got another one over here. Just got a random VDP on my desk. Come on, what are you doing over there? He's another dead one. Sorry, VDP, it's my fault. Right, so now we need to get another one open. How long have I got? Like 10 minutes. Uh-oh, I've just heard the door go. That's the missus. Can we get one swapped in under 10 minutes? I'll tell you what, get this board on the heat. Sod the head port for now, I can't be bothered with all that faff. Get this down. And this is like speed VDP swapping now, while also trying to not kill chips at the same time. Get you guys the overhead view, so you can see. Right, he's on there, getting nice and toasty. Oh no, it's the gate as well. Who could possibly? Oh, that's the kids ordering takeaway. That is definitely. Yeah, right, Zach's ordered a takeaway. It's just popped up on my phone. I'll let them get that. Right, so please be a 2-chip. I'll have to screw in. Why is it when you're in a rush? Oh no, what am I doing anyway? Yes, 2-chip. I'm warming the wrong board up as well. This board, you come off. You don't even need to warm up yet. We're meant to be warming up the board. We need to take the VDP off. Aye. we'll get there in a minute. There we go. Right, let's get this thing going. I am going to blast it with a bit of hot air to start with because the board's cold, so that really won't matter. Let's just get a bit of heat going. And then once this is warmed up a little bit, I'm going to remove it and transfer it over to this other board. So clean that dirty flux off now. That's enough hot air just to give it a helping hand. Going to get fresh flux ready on the whiteboard. And all I'd probably do in this case, now we know it's the heat potentially. Oh, I'm getting called a VDB killer now. Let me have a look. That can move out of the way now. Yeah, we can definitely do a bit more scientific test on this now, and you don't necessarily need to use the infrared because it's obviously quite slow, but it's helped us to prove that it is heat, you know, excessive heat on the chip. Well, like I say, we still could be talking the melamine sponge at the minute, but let's presume it's the heat. You can just lower the hot air temps down and figure out the right temps. You could also protect the chip with, I think somebody just mentioned that, like, you know, a ceramic chip or a heatsink on top. You could also get, I don't think I've got one. Maybe I have. Nope. You can get nozzles that have hot air channels around the legs and not on top of the chip. We could hot air the board from the underneath. There's loads of different things we can do. But the key will be, if we know it's heat, we can work around that. And if we know we see that failure, we know we've killed it with heat. It's very much likely we've killed it because I've never really seen that. The only other thing that stuck in my mind is I'd never really seen that visual on a VDP before, like that death, if you will. So that was something in the back of my mind that I'd never seen that visual. And now we know why. So I think at least if we see that going forward, it's likely we've killed it with heat. And we can just try different techniques to, the more we do and the more we swap over, the more we can be assured of, say we lower the temps on the hot air and we don't see them dying, and then we do it over and over and we get consistent results. The more we do it, the more we'll find out a temperature and a setting and a technique that works the safest. But for now, I'd recommend you guys crank down your heat and warm the board from underneath if you don't have one of these. That's what I'd recommend to start with. If you're taking these off, warm the board from underneath, not on top, and lower your temps. I'd say, oh shit, that was on that. I'd lower your temps to sorry, what is it with me in alignment? I should just leave it there a bit. Lower your temps to about 300 degrees. And also, you shouldn't really probably use flux, we figured out on this infrared, because it drips through and burns. So, come on, get on there. Yay, it's on. And, like I say, we're presuming it's the heat at the minute. Kapton tape won't protect much. No, it's not a thermal barrier. it's an airflow barrier, so to protect a little bit. But no, I'm not a massive fan of Kapton tape. That's good enough, I reckon. Yeah, it looks good enough to me. Then I'm stuck in this awkward thing again where I've got hot thing in my hand. Move you over there. Move you. Right, I haven't got time now to do another one, so I can turn that off anyway safely, because I'm not going to have time to do another infrared. I've got like 5 minutes, like at max. Yeah, I've got no more time after this one. I don't really want to kill another one, but I'm still going to attempt to. I do like how that solders it though. That is nice. That's clean. One little bridge. The only thing is, I did clean the board, didn't I, with the sponge? Didn't I clean this? Obviously, I cleaned the flux off with the melamine sponge when we infrareded, so I'm pretty sure it is going to be the heat has knackered it. Ordered a PS2 this month. Yeah, I've seen that PS2. I'll be building it. I'll probably build it on stream for you. It's going to be... I'm away for a week. When I'm back, I've got 4 to do. So, but yeah, it'll get there before Christmas, but it'll be probably 3 weeks, I'd say. Yeah, thermal pads are definitely probably a help as well, I think. I've got thermal pads, I've got heat sinks as well. This is a Game Gear that I've just discovered. I've been killing Game Gear babies for months now with heat. So I need to apologise to the VDP gods and thank the people that said I was doing stuff wrong, because I clearly was. But that's why you should always listen. So now I kind of don't want to clean that in case it's the sponge, so I'm going to leave that an ugly, messy mess. I'm sure I've got a suntan off this infrared though. I am burning up. Can I fix printers? Maybe. I don't want to though. What's a VDP? The thing I kill all the time. It's a visual display processor, I think. Video display processor. What am I doing with the Sega chips? Killing them accidentally, on purpose. I got to recap some SMD caps on a VCR. You can take off, if you go on YouTube, Retro 6 Live, go to the playbacks, you will see on the series where I am fixing a PC Engine GT, that's in the title, I show you how to measure all the capacitors and find values. Basically it's called an LCR meter. You want to take them out of circuit, put them through an LCR meter, and you can measure what value they are. You can also try and find a schematic. I'm kind of happy, because now I've got a bit more confidence in the VDPs. Like, that was starting to become a thing that, like, was going to be a problem, but now I know it's just me, that's ace. Of course, you know the next stream, though, is going to be all about finding the perfect way to kill a VDP. So we want to find that optimal temperature, in which case they screw up. I mean, they do sell, obviously, professional machines, but I like to be able to do it by hand and fast. But you can get like machines like this that are fully automated. Thermal probes that you put on chips, the right socket shapes, all kinds of stuff to do, you know, properly. But you don't. I've never had to do that before. This is one of those cases where, yeah, that's nice and cool. It looks like we need it. So, have we got another 1 minute? Come on. Yeah, see, so VDPs are fine. It's just me killing them. Right, let's kill it. Sponge time. While it's on. Oh, doesn't like that. So this disproves static problem. This is generating as much static as you'll ever see. Yeah, it's not going to be a static issue. Yeah, so it's been me all along. I feel like that guy on Shutter Island at the end, where he realises he's still being lied to. And I'm secretly a VDP killer, and I just don't know myself. Mega CD2. Yeah, I can do a clean power. I'm just doing I'm doing a lot of mods for the Mega Drive at the minute. I've just made. Why do I feel like I've seen it on my desk? I know I've seen it on my desk. Mega Drive 2 RGB. Where have I put it? I've literally seen that. Like genuinely, I've moved that out the way like 5 minutes ago. Well, before the stream started. Yeah. Anyway, a little board I've made for the Mega Drive 1 and 2. I've made a clean RGB. I'm gonna make more mods for like region switching and stuff. Right, you're gonna die with hot air. Unfortunately, VDP, I'm afraid. Let's find out. Turn my hot air down to 300. Zach will kill me if he watches this back, because we need VDPs for customers' orders, and I'm sitting here purposely killing them. Take the power out. Inch above. This is 300 degrees now. I'm going to do... I normally reflow for 2 minutes, so I'm going to start a timer for 2 minutes. Clock. Start. There we go. So I've got... Oh shit, I haven't got time. I'm a minute behind. I've got like... Genuinely the maximum time is 4 more minutes, and I've got to leave here. So we'll burn this for 2 minutes at 300, which is enough to completely solidify these pins. I could also put it on that overhead. Let's see this go molten. Well, I presume and hopefully it will go molten, because then we know we could remove it. And to be honest, I probably shouldn't, because what I'm going to recommend to do this is heat from underneath. So let's not be wasteful of these. I'd recommend we heat from underneath, like this, until it goes molten and we can lift it off and do a full reflow with basically a hot air gun underneath the board. That's the way I'm going to recommend you remove these. And that's it, I think. So let me save that for another correctly thought out and planned video, not rushing and purposely trying to kill these things. Well, that's a good find. So we now know pretty confidently it's not the USB port, it's not the melamine sponge. We've just absolutely annihilated that by, you know, rubbing it while it's on and everything. I think it literally is just too hot, killing the chips with heat. So let's turn that on. That's still quite hot. Let's turn him on while he's hot. Yeah, so he's still fine. Melamine sponge. That's as much cleaning as I'd be doing. So it's got to be the heat. That's bottom line. So yeah, even Zach said, "Oh, you're killing them with heat," and I'm like, "No, don't be silly. I know what I'm doing. I've done hundreds of these. Do you know who I am?" And then no, clearly it's me killing it with heat. So first time I've ever known a chip to die from 480 degree and like 1 minute 30. But obviously VDPs only seem to die. I've killed about one CPU which could have been faulty. I've got about 6 Z80s, and these get treated exactly the same. So it's not like, you know, the technique is wrong. I swap SNES chips, Mega CD chips, FRAM chips. You've seen me do it all the time with loads of chips. They don't die, but this VDP does die. So this is sensitive to heat. So it's not like the whole, you know, the process we're doing is wrong, but these are definitely fragile to heat, which is ace, because now we know it, we can protect them more and make sure we do the, you know, find a better way now of swapping these over. Right, so I better go. I've literally got like 30 seconds. So thanks everybody for joining in. Glad we discovered something new. Thanks for all the critics that have highlighted all the potential problems. That's why you should always listen to them. And yeah, if you're going to do these, ignore all my previous videos. Stop hot airing the VDP for now until I've done more tests. Either use some infrared or use the hot air station at 300 degrees from underneath, and be careful of these with heat, basically, is the answer. And yeah, we could still recover these VDPs. If the heat is what's killing them, it could be a single bond wire like he's mentioning, where we could actually drill down into these and find the wire that's broken. So I'll keep all these bad ones because I've got lots of them as well. Look at all these that died because they're just shit quality. I've got a tub full of these. So I could find, and like I say, the fact that they die exactly the same, there's a chance we can still recover these and find out which wire it is that's dying. It could also be just the fact that they're going to die under heat and it's the die inside, the actual silicon die, but I doubt it. It's more than likely a bond wire that breaks. So we'll see anyway. I'll get to the bottom of that. But for now, I will put them in my tub of even more dead VDPs. So we've got even more in here. Yeah, graveyard. Put a cross on him because I killed him. Sad face. There we go. So that's the final, hopefully the last VDP I kill. But yeah, nice to learn new stuff, and now we can hopefully stop having problems. We should be able to get a nice streak on these now. We'll have to go for a Game Gear win streak and see how many Game Gears we can just do in a row that don't die. Right, I'm going to leave this in a complete mess and disappear. Let me have a quick catch up on chat. What are we fixing today? We have just basically figured out the cause of constant dead VDPs, which turns out to be me and too much heat. We've solved it with infrared, super delicate, slow removal. We've done it twice to prove it, and I'm going to find the best way now to not have to use this infrared slowly to get VDPs on without them dying. So we just need a new technique basically. But for now I've got to run, so thanks everyone for joining in, and I might be back on tomorrow. Then I'll be away for a week, so you won't see me then until next Saturday. And yeah, I do make PCBs by hand, prototypes. Not all the time, because the factory's now doing them me for free, because I order so much. Oh yeah, wait till Rusty finds out I've been killing VDPs. He's not going to be happy. Right guys, I will catch you tomorrow. Pretty sure I'll be on tomorrow. You can watch it back on VODs as well if you want. On YouTube and Twitch you can watch this whole stream back if you want. VDP, no, they won't read correct if they're broke. On an LCR meter, sorry, not a VDP. I got VDP in the head. Find a data sheet or the VCR. Yeah, so same thing. Basically, yeah. If your cap's already dead, you can't test them. You'd have to get a data sheet. Yeah, loads of ideas. Keep them coming for how we're going to do this. And I'll try a bunch of techniques. My first technique's just going to be hot air from underneath. Is the first technique, and a lower hot air temperature. And then hopefully these things will survive.